Good afternoon, students. Today we start new topic, Foundations of Statistical Methods for Processing Biomedical Data. We'll have some lectures about statistics in medicine. And today we will discuss next questions. We will cover next questions. What is statistics? Types of variables. How can we represent data? Methods of descriptive statistics. Overview of methods of inferential statistics, and confidence interval for a population mean. The purpose of this presentation is to help you determine which statistical methods are appropriate for analyzing your data for your resident research project. It does not represent a comprehensive overview of all statistical tests and methods, but this lecture and practical classes we will have during our course is enough to perform individual assignment, which you need to defense during our course. Your data may need to be analyzed using different statistical tests that are presented here, but this presentation focuses on the most common techniques. Previous week, you passed first checkpoint, and now we start to learn medical statistics and methods of medical statistics. And after we finish this part, you need to make individual assignment and defense it. Let's start from the definition. What is statistics? There are different definitions as usual, but all they are similar. The discipline concerned with the treatment of numerical data derived from groups of individuals. A branch of mathematics dealing with the analysis and interpretation of masses of numerical data. Statistics is a science of collection, presentation, analysis, and reasonable interpretation of masses of data. Statistics presents a rigorous scientific method for gaining insight into data. Look at the fun definition of statistics given by Benjamin Disraeli. There are three kinds of lies: lies, demand lies, and statistics. It is easier to lie with statistics, but it is easier to lie without them. This is definition by Frederick Mosteller. And one more statement: statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Let's start. Why it is important to be statistically literate? Depending on the course you're studying, you may be required to collect, organize, and analyze different types of data. You need to present this data in your assignments. Then you need to interpret data presented in charts, tables, and graphs. So you need to present data by using graphical form. Then you need to estimate probability and make predictions based on available data. Medical statistics. Medical statistics is application of mathematical statistics in the field of medicine. Why we need to study statistics? There are three reasons. The first reason is basic because statistics is the basic requirement of medical research. Then second reason, we need to update our medical knowledge by using statistics. And we should study statistics for data management and treatment. Why we need for statistics in biomedicine? Due to two main reasons. The first reason is variation. Attributes differ not only among individuals, but also within the same individual over time. And second reason is the sampling. Biomedical research projects mostly carried out on small numbers of study subjects. Challenging problem to project results from small sample studies to individuals at large. Look at this slide. We divide statistics into some parts: descriptive statistic, correlation, and inferential statistics. Descriptive statistics is used to organize, summarize, and describe data collected during our research or during observations. Correlation or correlational statistics describes a relationship between some variables. Inferential statistics. We use inferential statistics to generalize our knowledge, our thinking, and we use it to estimate significance. What is biological variation? Necessitates the use of statistical methods in biomedicine to put numerical data into a context by which we can better judge their meaning. There are statistical methods used to produce statistical inferences about a population based on information from a sample derived from that population. It is impossible to study the whole population, so we can make our researches by using only group or only part, only portion of the population, which is called sample. And by using statistical methods, we study this sample, but we apply all the conclusions to the whole population. Statisticians need different types of data. There are different sources of data, the raw materials for statistics. The sources are shown at this slide. Routinely kept records, for example, hospital medical records or electronic medical records, different types of surveys, scientific experiments, clinical trials, data bases, and published reports. All the sources are used to for the patient's data. Any characteristics that can be measured or classified into categories is called a variable. A variable is very important element, very important item we use in statistics. Characteristics of patient that can be measured or classified into different categories. Let's look at the types of variables. Before we start any type of statistical analysis, we should understand which variable should be studied, which variable should be analyzed. All variables are divided into two subgroups: qualitative or categorical variables and quantitative variables. Qualitative variable describes quality of the variable. There are two groups in categorical variable, nominal and ordinal. The differences between nominal and ordinal is the order. Does order applied or not? Nominal, not ordered variable, and ordinal, ordered variable. Example of nominal variable are, for example, gender, male and female, two different possible values. And example of ordinal variable is, for example, response to treatment, weak, moderate, or high. As usual, in statistics, we use quantitative variables. In this type of variable, we use, as usual, numbers to describe this variable. There are two types of quantitative variable: discrete or count data, and continuous, real valued or interval data. Discrete, the number of example of discrete variable is number of admissions, for example. Example of continuous, height, weight, so a lot of medical variables belongs to the quantitative variables. Now let's look some more explanation. Qualitative variables, such as gender, ethnic groups, pass or fail in examinations, for example, blood group. So qualitative variables cannot be measured numerically. They are categorical in nature. For example, blood group. So we have four different categories: A, B, and fourth is O. If we are talking about gender, variable gender, it is possible to get male or female as a category, as values for this variable. Example of ethnic group, for example, Chinese, Y, Indian, others. So they are categorical in nature. Categories must not overlap and must cover all possibilities. And ordinal variables, categories are ordered in some sense. Examples are the response to treatment, unimproved, improved, much improved, or pain severity, no pain, slight pain, moderate pain, severe pain. So we can order according to the some criteria. Quantitative variables can be measured numerically, and a lot of variables are quantitative variables: height, weight, concentration, level of sugar. They can be continuous or discrete. A discrete variable is usually a count of something and hence takes the integer values only. Example is the number of admissions. A continuous variable, another name is the interval variable, can take on any value subject to precision of measuring instrument within some range or interval. Weight, height, blood pressure, level of cholesterol, and so on, level of sugar. Why it is so important to understand type of the variable? Variable types and measurement types have implications of how data should be displayed or summarized. determines the kind of statistical procedures that should be used. So the understanding type of variable which you need to analyze is influence to the methods of statistics, because we should apply different methods for different variables, types of the variables. All data comes from a population. In clinical research, the population of interest is typically human. The population is who you want to infer to. We sample the population because we can't measure everybody. So we can study only part of this population, which is called sample. Our sample will not be perfect. So the true random samples are extremely rare and we need to estimate random sampling error because we draw part of the population and take only some elements for studying. Look at the definition: population and sample. Population: the complete set of individuals, objects, or scores of interest. As usual in medicine, we investigate patients, so or different effects, often too large to sample in its entirety. It may be real or hypothetical. The results from an experiment repeated ad infinitum. Sample. Sample is a subset of the population. A sample may be classified as random. This means that each member has equal chance of being selected from a population, or convenience, what's available. Random selection attempts to ensure the sample is representative of the population. Two more important elements in statistics. Parameter. Parameter is a measure of population or a measure of the distribution of population. Parameter is usually presented by Greek letters such as mu, p, and so on. Parameters are unknown usually. To know the parameter of a population, we need a sample. Statistics. Statistics concerns to the sample, and it is a measure of sample or a measure of the distribution of sample. Statistics is usually presented by Latin letters such as m small, p small, and so on. So if you see in statistical papers Greek letters, this concerns to the population. If you see Latin letter, it concerns to the sample. Sampling error. The difference between observed value and true value is called as sampling error. There are three kinds of error: systematic error, it is fixed value; measurement error, random value; and sampling error, also random value. The statistics of different samples from the same population are different from each other. In the statistics, the statistics is different from the parameters, some different from the parameter. The sampling error exists in any sampling research. It cannot be avoided, but may be estimated. All estimation methods can be divided into two classes: point estimation and interval estimation. A point estimate is a single number only. How much uncertainty is associated with a point estimate of a population parameter? An interval estimate provides more information about a population characteristics. then does a point estimate. It provides a confidence interval for the estimate. Such interval estimates are called confidence interval, or CI, confidence intervals. Look at this slide. At this slide, you can see the estimation process. So we have population with unknown mean, which is denoted as mu, and the mean of the population is unknown. We can draw the sample from this population, some random sample, and it is possible to calculate sample mean. For example, x equals, in our example, x equals to 50. And if we use point estimate, the point estimate is one value only, and this value equals to 50. This is point estimate. And if we use interval estimate, we can make our conclusion. I am 95% confident that mu is between 40 and 60. So this slide shows differences between point and interval estimate. One more slide with explanation. So point estimate is only one point, only one value. A confidence interval provides a range of plausible values for the population parameter. As usual, point estimate is inside this confidence interval, which has lower confidence limit and upper confidence limit. P-values, the probability that any observation is due to chance alone, assuming that the null hypothesis is true. Typically, an estimate that has a p-value of 0.05 or less is considered to be statistically significant or unlikely to occur due to chance alone. The p-value used is an arbitrary value. P-value of 0.05 equals 1 in 20 chances. P-value of 0.01 equals 1 in 100 chance. P-value of 0.001 equals 1 in 1,000 chance. P-values provide less information than confidence intervals. A p-value provides only a probability that estimate is due to chance. A p-value could be statistically significant but of limited clinical significance. A very large study might find that a difference of 0.1 on a scale of 0 to 10 is statistically significant, but it may be of no clinical significance. A large study might find many significant findings during multivariable analysis. A large study dooms you to statistical significance. Confidence intervals provide a range of plausible values of the population mean. The most tests, if the confidence interval includes 0, then it is not significant. If we have ratios, if confidence interval includes 1, then it's not significant. The interval contains the true population value 95% of the time. If a confidence interval range is very wide, then plausible value might range from very low to very high. Example, a relative risk of 4 might have a confidence interval of 1.05 to 9, suggesting that although the estimate is for 200% increased risk, an increased risk of 5% to 900% is plausible. An interval gives a range of values, takes into consideration variation in sample statistics from sample to sample, based on observations from one sample, gives information about closeness to unknown population parameters, stated in terms of level of confidence, can never be 100 confident. The general formula for all confidence interval is shown at this slide. Point estimate, confidence interval means point estimate plus minus critical value multiplied by standard error. A confidence interval tells us what population values of the difference in means are consistent with our data. Values outside the confidence interval are ruled out. There are three different levels of confidence interval: 90% confidence interval, 95% of confidence interval, and 99% of confidence interval. So suppose confidence level equals to 95%. Also, we can write 1 minus alpha equals to 0.05. Alpha is the proportion of the distribution of the two tails areas outside the confidence interval. A relative frequency interpretation. If all possible samples of size n are taken and their means and intervals are estimated, 95 of all the intervals will include the true value of that their known parameter. A specific interval either will contain or will not contain the true parameter due to the 5% risk. Let's look to the different types of statistics which can be used to analyze different types of data. Descriptive statistics and inferential statistics. If we use descriptive statistics, we use it to describe phenomena, and descriptive statistics answer next question: how many, how much. We use descriptive statistics to analyze frequencies or basic measurements. We use methods of inferential statistics to make inferences about a phenomenon. The methods are hypothesis testing, correlation, confidence interval, significance testing, and prediction. We use inferential statistics methods to prove or disprove theories, to describe associations between phenomena, and to understand if sample relates to the larger population or not. The example is a relationship between diet and health. Let's talk about descriptive statistics method. Descriptive statistics can be used to summarize and describe a single variable. Another name for descriptive statistics is univariate. If we use single variable, univariate. There are different methods in descriptive statistics. If we have categorical data, nominal or ordinal, we should use frequencies or counts and percentage. If we need to describe data numerical or quantitative, we should use means and standard deviations. Means and standard deviations are used for continuous data. Examples are height, weight, level of cholesterol scores in tests. So we use descriptive statistics to characterize data set. We can use graphical way to represent our data set or by using table form. If we use graphical presentation, we should use different types of graphs, such as histograms, frequency distribution, box, and Whiskers plot. If we need to describe our data by using statistics, statistics describes a numeric set of data by three different characteristics: center, variability, and shape. Statistics describes a categorical set of data by frequency, percentage, or proportion of each category. So according to the different types of variable, we should use different types of methods in descriptive statistics. Before we go on, we need to understand what is distribution. It is an important term in statistics. Distribution of a variable tells us what values the variable takes and how often it takes these values. Data can be distributed or spread out in different ways. At these slides, you see different types of graphs. So it can be spread out more on the left or on the right, or it can be all jumped up. One of the most important distribution in medicine is the normal distribution. Many things closely follow a normal distribution in medicine. Heights of people, errors of measurements, blood pressure, marks on a test. Normal distribution. This is type of distribution where the data tends to be around the central value with no bias left or right, and it gets close to a normal distribution. At this graph, you see a graph of the normal distribution. Another name of the normal distribution is Gauss distribution, and graph is bell curve. All these terms is used for normal distribution. This is the most important. Normal distribution is the most important probability distribution in statistics and important tool in analysis of epidemiological data and medical science. Look at the characteristics of normal distribution. Normal distribution has a bell-shaped curve and it is symmetric. It is symmetric around the central value. Two halves of the curve are the same, mirror images. At this graph, you see different types of distribution of a variable. And look at the top level. You see distribution at the A graph with one peak. It is called as unimodal. At graph B, bimodal, because it has two peaks, three models with three peaks, and so on. Second level, the distribution can be symmetric, positively skewed long upper tail, or look at the F graph, negatively skewed long lower tail. Next level, third level, the distribution can be symmetric, the same symmetric with two peaks and this distribution is symmetric. By model with gap or another type of shape such as exponential shape. We can get distribution with spike in pattern G graph. At the key graph, you see some distribution with different outliers, and the L graph, it is graph transaction plus outlier. So there are different types of distribution of a variable. Due to the distribution, we can use different statistical methods. So the first is to understand which variable should be analyzed, and if the variable is quantitative, we need to understand type of distribution. What is frequency distribution? Consider a data set of 26 children of ages 1 till 6 years. Then the frequency distribution of variable age can be tabulated as follows in the next table. So we have two lines, age line and frequency line, and we need to put appropriate numbers, number of children according to the age. We can group grouped frequency distribution of age. We can group according to the age, and the table below shows grouped frequency distribution of age. We have age group in the first line and frequency distribution in the second line. The distribution of scores of values can also be displayed using box and Whiskers plot and histograms. Some later we will discuss how to interpret box and Whiskers plot. In the histogram, at this slide you see example of histogram of hemoglobin levels of 70 different women. For categorical variable, as usual, bar diagram is possible. Bar diagram lists the categories and presents the percent or count of individuals who fail in each category. Look at this graph. It is necessary for each graph, it is necessary to type title for the graph bar chart of subjects in treatment groups. And you need to type axis names. It is necessary. Treatment groups and number of subjects. The same information can be represented as a graph or as a table with columns. In the for categorical variable, we should use frequency and proportion. Another type to present categorical variable is by using pie chart. List the categories and presents the percent or count of individuals who fall in each category. So look, there are name of the graph and legend box with explanation what is each part for. Or we can use frequencies, proportion, and percent for each treatment group. But as usual, we analyze numerical variable. It is a lot of different methods, and one of them is by using graphs to depict numerical variable. Histogram or bar chart is the most often used. Overall, histogram overall pattern can be described by its shape, center, and spread. The following age distribution is right skewed. The center lies between 80 to 100. There is no outlines in this example. And to describe this numerical variable, we can use different statistics with values for these statistics. If we have frequencies and percentage, we can use different ways to represent frequencies and percentages. Look, the table way, pie chart, bar chart. So all these ways are possible to represent percentages and frequencies. If we have numerical variable, methods of center measurements are used to describe numerical data, or methods of location. Center measurement is a summary measures of the overall level of a data set. Commonly used methods are mean, median, and mode. Mean, most commonly used measure of central tendency, best applied in a normally distributed continuous data, not applicable in categorical data. And definition of the mean, you know how to calculate it. You need to sum up all the values in a sample, and you need to divide this sum by the number of values observed. Median, one more method of center measurement. The middle value in an ordered sequence of observations used to indicate the average in a skewed population, often reported with the mean. If the mean and the median are the same, sample is normally distributed. It is the middle value from an ordered listing of the values. If an odd numbers of values, it is the middle value. If even numbers of values, it is the average of the two middle values, mid value in interquartile range. And third central tendency is the central tendency value is the mode. Mode is the value that is observed most frequently. The mode is undefined for sequences in which no observation is repeated. Why do we have so many central tendency values, and how to understand which central tendency should be used? Mean, median, or mode. The median is less sensitive to outliers or extreme scores than the mean, and thus a better measure than the mean for highly skewed distributions. For example, let's take for the example family income. For example, mean of 20, 30, 40, and almost done 1,000 is equals to 270. The median of these four observations is 35. Here, 3 observations out of 4 lie between 20 and 40. So the mean 207 and 70 really fails to give a realistic picture of the major part of the data. It is influenced by the extreme value 990. So in this example or similar examples, you should use mean, or you should use median, not mean. If in the data set there are some extreme values which varies a lot from another observations. A fundamental concept in summary statistics is what of a central value for a set of observations and the extent of which the central value characterizes the whole set of data. Measures of central values, such as the mean or median, must be coupled with measures of data dispersion, average distance from the mean, to indicate how well the central value characterizes the data set as a whole. To understand how well a central value characterizes a set of observations, let us consider the following two sets of data. The data A. There are three values on in this data set, 30, 50, and 70. And B data set consists of three values, 40, 50, and 60. The mean of both two data sets is 15, but the distance of the observations from the mean in data set A is larger than in the data set B. Thus, the mean of the data set B is a better representation of the data set. That is the case for set A. Variability or dispersion measures the amount of scatter in a data set. Commonly used methods: range, variance, standard deviation, interquartile range, coefficient of variation, and so on. Range: the difference between largest and the smallest observation. The range of 10, 5 to 100 is 98. It is a crude measure of variability. One more statistics is variance. The variance of a set of observations is the average of the squares of the deviations of the observations from their mean. In symbols, the variance of the observations are shown. The formula for variance is shown at this slide. Standard deviation, one more important statistics. Square root of the variance. The standard deviation of the above example is 2. Coefficient of variation. The standard deviation of data derived by its mean. It is usually expressed in percent, and formula is shown at this slide. But you don't need to memorize this formula. You need to understand the sense of all these statistics, and the main is to interpret the results, because we will use special statistical software to get all these statistics. The main for you is to interpret results obtained. To describe numerical data, we can use graphical method, and we should use box and whiskers plot. This type of graph is called as box and whiskers plot. And in this box and whiskers plot, we use quartiles. Quartile is portion. Data can be divided into 4 regions that cover the total range of observed values. Cut points for these regions are known as quartiles. So the bottom point is the minimum value in our data set. The top is the maximum value in our data set. All another values are divided into 4 different quartiles. The first quartile we denote this as quartile 1, is the first 25% of the data in the data set. The second quartile is between 25th and 15th percentage points in the data. The upper bound of quartile 2, this middle point, is the median. The third quartile is the 25 of data lying between the median and the 75 cut point in the data. Quartile 1 is the median for the first half of the ordered observations, and quartile 3 is the median of the second half for the ordered observations. This is explanation of box and whiskers plot for the group A. In the graph, you see group B, and we can see almost the same graph, but it shows not quartiles, but it shows percentile. In the percentile, we divide data set into 100 parts. Percentiles. If data is ordered and divided into 100 parts, then cut points are called percentiles. 25th percentile is the quarter 1, 15th percentile is the median, and the 75th percentile of the data is quartile 3. In notation, percentiles of a data is the locative formula, observation of the data. There is P is the desired percentile, and N is the number of observations of data. If we divide our data set into 10 portions, into 10 parts, we use decimals. So it is possible to describe data by using quartiles, decimals, and percentiles. At this slide, you see the same box and whiskers plot, which is called 5, which gives us 5-number summary. The 5-number summary of a distribution consists of the smallest minimum observation, the first quartile, the median, quartile 2, the third quartile, and largest maximum value observation written in order from smallest to largest. A box plot is a graph of the 5-number summary. The central box spans the quartiles. A line within the box marks the median. Lines extending above and below the box marks the smallest and the largest observations. Outline samples may be additionally plotted outside the range. The 5-number summary is usually better than the mean and standard deviation for describing a skewed distribution or a distribution with extreme outliers. The mean and standard deviation are reasonable for symmetric distributions that are free of outliers. In real life, we can't always expect symmetry of the data. It's a common practice to include number of observations, mean, median, standard deviation, and range as common for data summarization purpose. We can include other summary statistics like quartile 1, quartile 3, coefficient of variation, if it is considered to be important for describing data. During our practical classes, we will use descriptive statistics methods and apply them to our real tasks. Another type of statistics is called as inferential statistics. Inferential statistics can be used to prove or disprove theories, determine associations between variables, and determine if findings are significant and whether or not we can generalize from our sample to the entire population. The types of inferential statistics we will go all over: correlation, t-tests, chi-square test, and logistic regression. So according to the different types of variable, if we need to analyze categorical data, we should use correlation or hypothesis testing. If we need to analyze the continuous data, we should use chi-square test or logistic regression. Correlation. What is correlation? How to use correlation? When do we need to use correlation? If we want to know about the association or relationship between two continuous variables, we should use correlation. We should apply correlation analysis. For example, if we're interested in food intake and weight, does our weight uh, depends or depends of food intake, or for example drug dosage and blood pressure, air temperature and metabolic rate. In this case, we should carry out correlation analysis. What does correlation tell us? If a linear relationship exists between two variables and how strong this relationship is. How to carry out correlation analysis? We should calculate correlation coefficient, which is denoted as R small, and we need to make correlation graph. To get correlation coefficient, you can by using special statistical software. The correlation coefficient ranges from -1 to +1. Let's look at the possible correlation results. If we get, you don't need to memorize the formula for correlation coefficient because all the statistical applications calculate this correlation coefficient. If correlation coefficient varies from 0 till 0.25, we need to make our conclusion there is little or no relationship, there is lack of relationship. If it falls in the range 0.2 to 0.5, we need to make fair degree of relationship or weak relationship. If correlation coefficient varies from 0.5 till 0.7, moderate degree of relationship. And if R is greater than 0.4, we can make our conclusion that there is strong relationship. If we get correlation coefficient equals to 1, this means perfect linear relationship, perfect linear correlation. Look at the graphs. So for a perfect linear relationship, the graph is the top left graph, maximum positive correlation, R equals to 1, and below this graph there is minimum negative correlation. In this case we have R equals to -1. Look at these two graphs. At this graph the absolute value for R equals to 1, but the sign is different. Top is with positive sign, bottom is with negative sign. Look at the graph. So we can interpret correlation according to the direction. If for positive sign all points goes upward, for negative sign all points goes downwards. In the middle, in the top middle graph, we have strong positive correlation because R equals to 0.8. Look at the graph. All points are located, but tends to move to the some invisible straight line. If we have correlation coefficient, look at the right graph, top right graph. Zero correlation or lack of correlation, r equals to 0. We have all points from our data set scattered plotted. In the bottom line of the graphs, in the middle, we have moderate negative correlation. Correlation coefficient equals to minus 0.4, and graph looks like this one. And the last graph, strong correlation and one outlier. Correlation coefficient equals to 0.7 because of one outlier. How to interpret correlation coefficient? If R is positive, high values of the variable are associated with high values of the other variable. Both go the same direction. If one increases, second also increases, or if one decreases, second also decreases. The examples of positive correlation is diastolic blood pressure tends to rise with age. Thus, the two variables are positively correlated. If R is negative, low values of one variable are associated with high values of the other variable. So variables go opposite direction. If one variable increases, another one decreases, or if one decreases, the second one increases. The example of negative correlation is heart rate tends to be lower in persons who exercise frequently. The two variables correlate negatively. Correlation of 0 indicates no linear relationship. How to report correlation coefficient? Examples see at this slide. Diastolic blood pressure was positively correlated with age. R equals to 0.75, P less than 0.05. Correlation does not equal causation. Just because two variables are highly correlated, this does not mean that one causes the other. T-tests. When to use t-test? Next, there are different types of t-tests, and we'll have a full explanation about t-test during next lecture. So I missed this slide because we'll have how to report test results. This is a slide about how to report them, but we'll have full lecture. So at this slide you see, before we finish our lecture, look at this table with summary of different statistical tests. We use correlation if we need to analyze two continuous variables, and we need to calculate R correlation coefficient. Examples are R blood pressure and weight correlated. We should use t-tests from means from a continuous variable taken from two or more groups. Chi-square test we use for two categorical variables, and logistic regression we will use a dichotomous variable as the outcome, but we will have next lecture about all of these methods. Today, now let's summarize. Descriptive statistics can be used with a nominal, ordinal, interval, and ratio data. Frequencies and percentage describe categorical data, and means and standard deviations describe continuous variables. Inferential statistics can be used to determine association between variables and predict the likelihood of outcomes or events. Inferential statistics tell us if our findings are significant and if we can infer from our sample to the larger population. Before we finish, I want to predict you for our practical classes in statistics. You need to install special statistical software to your computers. You can install it from Yandex Disk. At the Yandex Disk, there is special subfolder which is called medical MedStat. You should copy all the files from MedStat into your computer and start MedStat file. You should use MedStat to calculate different statistics and to analyze medical data. If we have practical classes online, you should use MedStat installed at your computers. If we have real classes, you should use MedStat. We have installed MedStat in our computer rooms. We finish with today's our lecture. Next class we will go on with inferential statistics method. Thank you for attention. Bye.